Hello everyone, welcome to today's live broadcast, Vibration, Noise, and Ultrasonic Noise from Vivarium and Lab Equipment as Rapidly Growing Compounds in Animal Research, presented by Dr. Jeremy Turner. We're excited to bring you this educational web seminar presented by LabRoots. To learn more about LabRoots, please visit www.labroots.com. I'm Leanna Pantier of Otoscience Labs, and I'll be your moderator for today's event. Before we begin, I'd like to remind everyone that this event is interactive. We encourage you to participate by submitting as many questions as you want at any time you want during the presentation. Just click on the green Q&A button located in the lower left of the presentation window and type your question into the box that appears on the screen. We'll answer as many questions as we have time for at the end of the presentation. Also, please notice that you will be viewing the presentation in the slide window. To enlarge the window, just click on the screen icon located on the lower right. Finally, if you have any trouble seeing or hearing the presentation, please click on the support button at the top right of the presentation window, or use the Q&A button to let us know that you're having a problem. Now, I'd like to introduce Dr. Jeremy Turner. Dr. Turner is the co-founder and CEO of Otoscience Labs in Jacksonville, Illinois, and also a professor at Illinois College. He has been conducting research on hearing in mice and rats for 20 years and has received funding from the Tinnitus Research Consortium, National Institutes of Health, and most recently the Department of Defense Psychological Health and Traumatic Brain Injury Program. His current research focus includes aiding animal research facilities in the measurement of noise and vibration in animal spaces and helping others to better understand the effects of these variables on biomedical research. In 2007, Dr. Turner was asked to be a guest editor of a special issue of JLAS, which centered around the issue of noise and vibration in animal research facilities. Please join me in welcoming Dr. Turner. I'll now turn the presentation over to him.
Okay, welcome everyone. Thanks for tuning in, and we'll get started. I'm planning on sharing some information with you for 40 to 45 minutes maybe, and leaving a good 10 or 15 minutes for questions and answers. So please submit those questions. So the main focus today is to begin understanding the impacts of noise and vibration in animal facilities, what it can do to our biomedical research in a variety of areas. And traditionally, I have worried about this for the last 20 years as it impacts the hearing research that I do. I'm a hearing research scientist and have been so for quite a while, studying how rats hear, how mice hear, and how we use them in models for human hearing. So I'm interested in the stress impact of noise and vibration. The basic structure then for what we're going to do today. For me, this adventure got started in around 2005 when we put together a review article on the auditory and non-auditory effects of noise on research animals. And this was basically an opportunity to share with non-hearing researchers what their animals heard and why it would impact them in various ways. Pointing out, for example, that a lot of the strains of mice we use are deaf or near deaf, and that the sounds that are in their environments may or may not impact them because of their hearing range and various factors that we'll get into today. In 2007, we actually were able to put together a special issue of JLAS, so you can still get access to that. I encourage you to do it because there are some remarkable chapters in there on acoustics and ultrasonic communication and how sound is measured and things of that sort. But the bottom line is that noise matters and vibration matters, and it doesn't matter whether you're looking at cancer or diabetes or immune system responses. These variables serve as confounds for the research that we do, and we need to understand them. So this is basically a summary of what we're going to talk about. This is, in a nutshell, what we're going to see. Noise and vibration experienced by our animals impacts every area of biomedical research, and I hope I can get that to you today. So as you're having conversations with colleagues, with PIs, with others in the facility, recognize that this is not just about people who study hearing and people who study vibration. Once stress systems are impacted, you can impact the entire organism, its behavior, its brain function. It's remarkably important and understudied. Noise, ultrasonic noise, and vibration, they're present in every research facility we've been to. We've measured from many facilities and laboratory spaces, It's ubiquitous. It's everywhere. These confounds are. And the variability from institution to institution is great, from vivarium room to room is great, and even within the same room we see major variability in noise and vibration from rack to rack, from location to location within a vivarium room. So understanding these measures are critical to gaining a control on our 3 R's actually. So these stimuli have their wide-ranging impact because of the stress they induce on animals. It's not because it's causing hearing loss in them, and that's been the traditional concern. We'll talk about why that is momentarily. The bottom line here is that it ends up causing us to use many more animals than we have to. Imagine for a second a scenario whereby you've got 2 racks of mice in the same vivarium room. One rack is shooting off an ultrasonic noise that's stressful, and it is also vibrating violently because of the rack top motor going bad on the top. And the rack right beside that rack is not. And you're putting those same animals into the same study, and you're seeing high variability. You have to use more animals. You can't repeat studies from lab to lab. A new PI moves to your facility. He's like, I can't repeat anything I found in my last job. So it makes for major frustration among PIs. And of course, the facility, director, head vet, and staff, they get blamed for these problems, even though it's not clear whether they're even there. So one of the bottom line messages is that we need to start measuring this. It's as important as measuring whether the lights are on or off. We would go crazy if we didn't know whether the lights were on or off in our facility. We would go crazy if we didn't know what ingredients were in the food that we give the animals. We would go crazy if we didn't know, what organisms our sentinels were exposed to. But we don't go crazy because of noise and vibration. For some reason, we're not interested enough in this problem, or we don't understand it well enough to begin measuring it. So we think we should start measuring this routinely. And in fact, once you find a problem, it's pretty easy to fix it when you identify it, whether it's noise or vibration. It actually can be used as a really good measure of the health of your equipment, whether you're talking about lights or motors. It's routine actually to use noise and vibration as measures of condition monitoring status. If you're in an industrial setting, for example, you can measure the acoustics of a motor and tell whether it's going bad. We can do this. It's not that hard, and it impacts our animals in very negative ways. So a major point to recognize here, and some of you, of course, do recognize this, but I want to note that what animals hear, we're going to start with hearing today and then move to vibration. What animals hear compared to what we hear is very different. So if you look at this plot, this was adapted from that 2007 or 5 paper that we did. What we have here is basically the hearing range of people. And so we people can hear sounds from 100 or 200 hertz. My voice is around 150 hertz, for example, right through here. Right through this point is where my voice is going to be. Unfortunately, if you look carefully, the mouse in red and the rat in orange, these are their curves way out here. They hear these really high pitches that we don't hear. Actually, anything above 12 or 15 kilohertz, it has to be pretty loud for us to hear it. And so the problem here, of course, then, is that all the equipment in our facilities, a lot of it is generating noise up here that we don't hear. And it's impacting our animals, and they're communicating up there, and we don't even know it. In fact, if you're just looking at a human voice range, the mouse, for example, right here, has a really hard time hearing a male voice. Some harmonics in a female voice can bounce up here, and the mouse can hear it. Some harmonics in a male voice as well, but ultimately the mouse doesn't hear the human voice very well at all. So that's an important point to keep in mind. We'll also talk about how the sound up here, these high frequency sounds, they behave differently than the sounds down here. These lower frequency sounds bounce around corners, they go under doors, they move easily. These high frequency sounds are very directional in nature. So once we find one, we can actually cut it out. We can deflect it. We can do various things to minimize its impact. So again, this is the human speech range, and this is the rat and mouse speech range, for lack of a better word. This is where they vocalize. This is where they communicate. If you want to stress out a rat or a mouse, you're going to use a sound up here. It's really effective. These these different animals' abilities to process these different sounds doesn't just happen by chance. It's because they actually use them to communicate. So these are actually vocalizations from rats. These are from spurred Growi rats. And notice the sound frequency here. Remember, we people only hear up to about this 20 kilohertz line right here, right? So this sound down here we can hear. Up here we can't. These rats are talking to one another. They're communicating. Much more is known today about rat vocalizations and mouse vocalizations and why they're used and how they're used. We have no idea that they're communicating, and whether you house them individually or in groups or same-sex groups or opposite-sex groups, you can get very different vocalizations. The point is that sounds up there matter to them, and so when we have those present in the environment, it can be intrusive. Mice, similar story. These are just different panels from that '07 journal review that we did. This is by Christine Portfors. Really beautiful calls that mice exhibit, high frequencies. And you can see, of course, that mice, we've all heard it, mice will squeal too in the range, really low frequency range that we can hear. But they have all this beautiful, complex, high frequency responses out there that they emit. So these high frequency sounds, if they're present, they can be problematic for animals. The guide, starting in this last edition, really began to take this issue seriously. So there are several places in the guide where this is brought up, noise and vibration, and in particular ultrasonic noise is mentioned more and more. And so I just want to point out 3 of these locations in the guide where this is brought up, and I'm going to underline the should statements because they're important. The point to this location in the guide, this is in chapter 3 where we focus on environment, housing, and management. The point here is that many species can hear sounds that we can't, these ultrasonic sounds, and they can come from equipment like the computer screens, lights, lots of anything mechanical ultimately in the vivarium space. That would be research equipment as well as rack top blowers, cage changing stations. Those can serve as ways to introduce noise and ultrasonic noise and vibration actually, and should therefore be carefully considered. So the equipment that you're using, you need to take into account the hearing in those animals. Under the physical plant section in chapter 5, the point here is that the location of equipment is important. Obviously, where possible, you want to select equipment for facilities that does not generate ultrasonic noise. Unfortunately, most equipment manufacturers don't provide any documentation about whether their equipment does this. So you're almost at the mercy of whatever you have available. So you basically have to measure it ultimately, but it should be considered. And then finally, in chapter 5, point here is that when you're dealing with the building structure, when you're dealing with building a new structure or doing remodeling, you ultimately want to make sure that you understand the equipment, the HVAC, all the potential sources of noise, ultrasonic noise, and vibration, and isolate them from the animals as best you could. So obviously in a perfect world, we put all of the mechanical equipment in an interstitial space, on another side of the wall. And that's not always practical or possible. But we should be selecting our materials based on these principles. We should be designing and choosing components that minimize these factors. We should be doing more, and that is the point. And I actually think that in the not too distant future, it's going to be expected that every facility provide some documentation of the noise and vibration metrics in their facility, just like it's important that you log, the daylight timers, whether they're on 12/12 and what time they're on and what time they're off. I think noise and vibration is equally as important. One of the problems with noise is that as we talk to people about this, they think that the only problem with noise is that it causes hearing loss, and this couldn't be further from the truth. Noise does, in fact, cause hearing loss, but only if the noise is up above this level here. So what this slide shows us is how intense sound is, and we worry about anything above 85 dB. So if you're exposed to an 85 dB noise for an 8-hour workday, OSHA says you've got to be careful. This can actually cause permanent hearing loss. We actually see in a lot of vivarium spaces noises at this level or higher in cage changing stations, and in fact we've been in some facilities where the racks that are closest to cage changing stations or rack top blowers can actually have sounds of 90, 95 dB present, and that can actually cause hearing loss in those animals. definitely can cause stress. But more importantly for the present talk is the recognition that it's actually the sounds down here that are known to cause stress. We all know that if a vacuum cleaner is running around us, if that were there all day, every day, that would drive you crazy. And yet, you know, if we have a 75 dB signal coming from a racktop blower all day, we don't even know it's there sometimes. Conversation, 60 dB. Living in the city, urban residents with traffic outside, 50 dB. So the point is that while these sounds aren't loud enough to cause hearing loss, they are loud enough to activate stress pathways and can do so in really dramatic ways. We are very concerned about these noises. I actually come at the study of noise and vibration from, you know, the hearing research side, of course, but I study specifically tinnitus, so I'm interested in ringing in the ears in rats and mice. So we model tinnitus in a lot of people as basically a form of inescapable noise exposure that causes stress. And so if you have ringing in the ears, you may sympathize with this. And we're effectively giving our animals tinnitus that is in the environment. It's not in their head when we have these sources of sound in their environment. Not good. Not good if they're going into a cardiovascular study, a stress response study, an immune system study, huge confound. And I won't get into this very much, but just recognize that ultimately when sound comes in, it activates whole networks. The entire brain becomes activated. If you really want to stress out an animal, you can use noise and vibration. In fact, a lot of people who study stress for a living use noise and vibration as stressors for their animals, for their animal models. It has wide-ranging neurological impacts and then behavioral impacts on any number of metrics. There's a lot more information on this elsewhere. By the way, anybody who has any additional questions, I can answer them offline or send you papers that can fill in the detail. So a couple of summary points here. These are some of the non-auditory effects of sound in lab animals, just a small sampling of them. We know it can increase blood pressure, heart rate, do all kinds of cardiovascular things to animals. It can activate lots of stress hormones and other neurochemical pathways, but it can impact breeding. It can change estrus cycle. It can alter fertility rates, change really significant things via reproductive processes. So when you notice animals not breeding, when you notice them behaving differently, start to look for noise and vibration as concerns. Interestingly, a lot of these same things that we see with noise, we see in vibration, so they're very similar. In fact, noise is vibration in the air, ultimately, so they're really the same basic phenomenon. It's just a matter of whether it's propagated in the air or in a solid substance. We actually know quite a bit about the effects of noise on non-auditory systems from people. Actually, this is one of those areas where we learn more from people that we can apply to our animal models. A lot of the performance issues that we see with low levels of noise, we know from human work. So, for example, if you're at a workstation and we have a fan on your computer that's not that's pretty loud, we can show that you actually will have more errors than the person in the next room who doesn't have a loud computer. These can be 45 dB or 50 dB loud. These are really relatively quiet sounds, but they're enough to activate stress pathways, and you're not even aware of it. You don't process it as stress, but your body does. So it can impact attention, performance, irritability, mood, all kinds of decision-making processes can be impacted. And it doesn't, this is not a stretch for us all to imagine. If we're ever trying to work in a relatively noisy and complex environment, it's very difficult to do that in any kind of advanced cognitive way. It impacts our sleep. So a lot of the animal models, obviously, we're not monitoring, them 24 hours a day, so we don't know what they're exposed to when we're not there. We know that when we're in there working, we're creating a lot of noise and vibration, and of course, oftentimes, this is going to be a part of the day when they're actually asleep, during a light phase. So their sleep becomes disrupted major time by the noise and vibrations that are in their environments. Won't get into that too much, just try to move on here. So we need to distinguish between macro and micro noise, and actually the same goes with vibration. So the sources of macro noise will include, cage washers down the hall or across the hall. the wheels on carts that you use to transport bedding into the room or animals in and out, the doors and their closers, whether they squeak, whether it shakes the room when the door shuts, the ventilation system, the lights, fluorescent lighting, and LED lights actually can produce ultrasonic noise, and we can measure this pretty easily. Any electronic equipment in the vivarium space and in the laboratory can create noise that we don't hear, and this is frightening. Actually, it's actually much more dramatic in laboratory spaces in our experience. When we go to a facility, the vivarium spaces are relatively clean because we don't have oscilloscopes and tons of computers and all kinds of behavioral testing control computers that you walk into a lab and try to measure the ultrasonic noise, and it is terrible often, really complex video cameras and all kinds of electronic equipment generating a complex acoustic environment for the animals, introducing variability. Of course, every building and room is going to have its own acoustic features, whether there's ventilated caging in the room. We're increasingly using ventilated caging because of some of the benefits it brings, but it also brings problems, so we need to keep that in mind. The microenvironment, however, is what actually reaches the animal. This is going to include sources of noise that will vary depending on how many animals are in the cage, whether you have enrichment devices in the cage, the type of caging used. Static caging versus ventilated caging is going to produce very different kinds of noise and vibration features. We routinely measure inside cage noise and vibration as well as outside the cage, macro, and a lot of the ultrasonic noises in the macro environment don't make it to the micro, don't make it into the animal. So I have a couple plots to show you to demonstrate that. These high-frequency sounds in the vivarium are really directional. They act like lasers, so you need to imagine the echolocation occurring in a bat. When a bat shoots out a high-frequency sound, it's using that sound's behavior as it bounces back like a laser from an object to tell it where something is. So the high-frequency sounds in a vivarium will act like ping-pong balls. They will act like lasers as they shoot out. So if you can identify the source of the ultrasonic noise, whether it be a light or a rack top blower motor or a timer or a computer, you can block them easily. You can isolate them away, but if you don't know they're there, you can't do that. So knowing that they're there is the start, and then fixing it is actually pretty simple. High frequency noise drop dramatically with distance as well. So if you've got a light generating 70 dB of ultrasonic noise, you can actually show that 4 feet lower where the animal is, it's dropped to a level that's not audible sometimes. So knowing the intensity is an important component, as well as the frequency. So the lower the frequency, the more these sounds will bend. And so we have to worry more about them, actually. So this is got a few snapshots here, some data we've collected in different environments. This is a typical measurement from a light. Fluorescent lighting, which is pretty typical in our facilities, is going to generate ultrasonic noise pretty much always. In this case, we've got signature sounds here and here. This spot here at 22 kilohertz, this would be audible to the animal. This 35 kilohertz would be audible to the animal. These would be problems if you hear them all day. And you might think 30, 35 dB, 40 dB, that's not so loud. But the typical tinnitus sufferer experiences his tinnitus at 15, 20, 25 dB. It's not especially loud. It doesn't have to be loud enough to cause hearing loss. If it's there all the time, it can be irritating and can interfere with communication. In fact, for example, in rats, we know this 22 kilohertz region is critical for a kind of an aversive call. So anytime you see something in the 20 to 25 kilohertz range coming from motors, which is really common, frankly, you worry about it activating stress pathways because of its acoustic similarity to a stress call. Anytime you have metal keys on your caretaker's body, as they enter the room, as they put them in their pockets, they will generate enormous ultrasonic noise problems. So this is just an example of keys jangling. And again, point out here that this 20 kilohertz frequency, you hear everything below this. So we can hear the keys jangling, but we don't hear this, and our animals hear it really, really well. In fact, it used to be in the audiogenic seizure literature that the way you would induce seizures in seizure-prone young mice would be to jangle your keys, and this high-frequency component would drive them crazy and produce an audiogenic seizure every time. So the point here is that if you use metal keys, put rubber bumpers on them, and most of us go to card systems and other access systems now, but if you still use physical hard keys, try to find a way to isolate them from the animals. Computers. If you have computers in your vivarium space, which is increasingly common to enter data, to log data, to control telemetry systems, to do any number of things, be very, very, very careful, because every computer that we've measured, every desktop computer especially, generates high frequency noise. So these are two different computer desktops that we measured in a lab. This is a 70 kilohertz sound that's nearly 60 dB. So conversation level is about 60 to 70 dB. So imagine that a conversation level tone all day is there all day long, and that's what this computer is going to do. So if you bring the animal over, for example, to your desktop to give him an injection for a blood pressure study, let's say, you set him in this environment while you're prepping, and he's getting exposed to this tone that may be stressful. You're going to introduce variability, and if the other animal's on the other side of the computer, the acoustics are going to be different, and maybe some of the time there's something blocking it, so it's not there. So just recognize that the variability can be great, and every computer will have a different signature based on the electronics on the inside. So telemetry units, they seem pretty pretty benign, right? But those systems can generate ultrasonic noise. You can see this signature here. Just a couple other examples. This is frightening. These little mobile temperature and humidity meters that we all have in our facilities, sometimes they're on the wall, sometimes they're on the countertop. They actually generate, through power switching mechanisms in the back, a high frequency sound here. You can see this one. This is 55, 60 dB almost, in a high pitch area that we don't hear. Basically every one of these we've measured has that. Rack top vents, this is a concern for a lot of people. There are as many styles as there are labs, it seems, but ultimately anytime you place a motor with moving mechanical parts above the animals, you have to be careful. This is an example of what some of these might look like. About a 55 to 60 dB signature up around 40 kilohertz. So ultimately there's something in there oscillating about 40,000 times a second. It could be power, it could be bearings going bad. And you can actually measure this over time and watch these things age and see that the ultrasonic noise gets greater and greater and greater and will move lower in frequency as the system ages and the mechanical parts get older and older. So sometimes you have to just replace a blower motor or oil something or replace a component. If you know it's there, you can start. Those of us who have rack top vent systems, they often have hose connections on them. Make sure you routinely check those hose connections. Make sure you routinely tighten them. This is an example of one room. There was quite a bit of noise coming from this particular rack. We tightened the hose connection, and it took away a lot of that noise. It really cleaned it up dramatically. Let's see. I have an example here of 3 different rack top vents measured at the exhaust vent. These are all the same manufacturer, and you can see these 3 different systems have similar mechanical properties. So they're all shooting out a 20 kilohertz sound and a 40 kilohertz sound. This is ultimately a harmonic. It's the same signal, harmonic of the other one. And again, we're not hearing these signatures, and the animals will be, and especially those animals right under the rack top blower unit. They're likely going to hear it. Let me jump through this because we're actually running behind. I'm going to actually make sure I can get the slides to you folks as well, because I think you might find them useful. I want to point this out because in my lab, actually, these showed up a couple years ago. And if you ever see in a vivarium space or in a plan for building or construction a format of turning off the lights that uses something that looks like this, then you should say don't do that, because this is a big problem. So these are light motion sensors. So these are designed to basically use ultrasonic noise. You can see the little speakers in the front. It'll shoot out ultrasonic noise and measure what bounces back, and it uses that to detect movement. And if it detects movement, it'll keep the lights off. If it doesn't detect movements for a certain amount of time, it'll turn the lights off. So this ultrasonic detector, we found, produces a 126 decibel sound. It is absolutely intense. That's actually loud enough to deafen your animals if they're close to that for like 5 minutes. It would be devastating. This is what it looked like. So it was about 40 kilohertz. We have no idea that sound is there because we only hear down here in the lower frequency area. So the fact that this area through here, I'm trying to use the wrong tool, sorry. The fact that this area through here is producing 126 dB. If you were to bring a rat or a mouse or a dog or a cat into that space, they would freak out. The dog would be barking at the wall, the cat would go nuts. The mouse, if it's certain strains like DBA, early C57, and they're really young, they're going to have seizures. And we don't even know it's there. So don't allow those things to be put in corridors, lab spaces, vivarium spaces for sure. The one particularly concerning area, and a lot of vivarium directors and vets don't really have control over this. Sometimes there are common behavioral research areas in those spaces, but ultimately where animals are taken to do testing is usually very, very much more noisy, acoustically and vibratorily. In this particular situation, we're actually measuring ultrasonic noise produced by some lights that are directly above a open field test. So this open field test, many of you have seen it before. Oftentimes there's a camera above and of course lights. And in this particular case, there's a ultrasonic noise present from the lights right above the open field test. Imagine if this is present in a Morris water maze where the animals have to learn where the location of a platform is. If you've got a light off to one side generating this high frequency buzz, it's serving as a directional cue. We don't even know it's there, and it's not routine. If you look in that literature, in these behavioral studies literature, they don't routinely measure these things and know that they're there. And again, we're increasingly using video cameras and computers to monitor such stations, such testing. So keep an eye out for it. Cage changing stations are notorious for producing noise and vibration. Major problems. So when you're choosing cage changing stations, please try to choose ones that are more quiet. Look for people that advertise ones that are more quiet, and if you have to put the animals in there to change their cages, be sure to minimize the amount of time they're in there. If possible, put them on rubber mats while they're in there because the vibration levels are routinely enormous. They're routinely very bad. So expect animals to be stressed for a couple hours after getting cages changes. And it's frankly not as likely to be due, I think, to the handling of them than it is to the noise and vibration that they got exposed to. So, you're going to see an acute stress response, but you're going to see a delayed stress response because of stuff like this. So you'll see a corticosteroid response 15, 20, 30 minutes after a treatment like this. So very problematic. So rule of thumb here, anytime you've got rats or mice in an environment that is complex with computer screens, computer terminals, you've got compressed gases that can leak out. We didn't even talk about that, but when you open a soda and you first start to open it, it squeals a little bit. Before you can hear it, it's producing an ultrasonic noise. And so anytime you have compressed oxygen, CO2 tanks, even vacuum lines, you have to check the connections. They could be squealing, causing stressors to animals. So it's remarkable how much stuff can actually produce this information, this noise and vibration that we're not even aware is there. So quickly about vibration, I want to spend some time on this. Again, very similar to noise with respect to how it induces stress. It is a known stressor. It is used as a stress induction model. Remember that rats and mice are, they're basically evolved to live underground, and they don't see well. So a great way to stress them is with sound. They communicate well with sound. It works well in tones and with vibration. So it is important ecologically to recognize noise and vibration as an issue. So there are day-to-day vibrations that our animals experience. These are going to be routine. They're going to be there all the time, a little more predictable. People coming in and out of the facility at usually similar times of the day. They have carts, they walk, they make their noise, they slide cages and racks in and out and move stuff. Predictability is a good thing when it comes to noise and vibration as far as the animals are concerned. But we have a lot of day-to-day stuff. We can't really control a lot of this. We don't generally know it's there, but it's there every day. There are also temporary sources of vibration. These can be more problematic if you think about it, because the animals can't predict when they're going to happen or what's going to happen. This can include construction that comes up all of a sudden. The animal starts to hear noise or feel vibration. Maintenance activities in the area, and transportation. I underline transportation of animals because and I have a figure to show you in a second. Just the vibration induced by transportation is some of the most confounding that we have. The vibration levels are through the roof when you're putting an animal on a cart and wheeling it somewhere across a facility. So don't expect that animal to behave normally for hours after that. The vibration has a lot of the same negative impacts that noise does. It can impact breeding, it can impact food intake, weight gain, any number of things. And this will be species dependent, it will be level dependent, dose dependent. It's kind of like noise. And so you have to know what the vibration level is. You have to know whether it's high enough to induce stress. You have to know what the frequency of that is in some cases to know whether they can even sense it. In humans, we actually know a lot more about vibration impacts. It's been studied more intensely. We know how it can impact all kinds of cognitive processes, sleep processes, behavioral and neurological function. It is remarkably good as a stressor for people as well. In fact, OSHA has 8-hour exposure limits, just like they do with noise. And it turns out that the level that OSHA sets as their 8-hour exposure limit, which is 0.5 meters per second squared, this is basically an SI standard for measuring vibration of acceleration. So 0.5 meters per second squared is the standard. So if you're exposed to that for an 8-hour period a day, OSHA says that's a problem. So if you're running a jackhammer, if you're doing anything with that level of vibration, beware. At 0.8, we actually have the experience of being uncomfortable. We want to get away from that. So it turns out that this 0.5 level is actually the same level known to induce stress and other problems in animals. It's actually kind of fortunate. We're lucky. There's not as much research on animals as people, but we know that this level is a concern. And so we keep our eyes out for that level. The threshold of detection is similar for animals and people. For rats, mice, and people, it's about 0.01 meters per second squared. So that's the level of vibration that you can actually tell is there. That's the threshold. And that level where we actually engage, that we actually think something should be done, is 0.5 meters per second squared. For the same reason we see the exposure limit in people, it's at that point that it causes lots of biological and behavioral impacts. So that level is based on some literature that I can share with anybody that's interested. There are a few studies out there on this. I'm just going to highlight a couple of really cool figures that I think are interesting. The construction process is known to activate stress pathways in animals. In this particular study, Rath and colleagues found that plasma corticosterone levels were elevated during construction compared to before and after. And so it's clear that the animals can experience this vibration, they can respond to it, and it's something we have to worry about. But not just during construction, during many other aspects as well. So this is the figure I mentioned earlier that I would show. These are vibration levels in acceleration, meters per second squared. It's small, but meters per second squared, as a function of transporting animals. And this is super frightening. So that 0.5 level that I was telling you about is right through here. So this 0.5 level, I'm going to guesstimate here, it's somewhere right through there, right? So anything above that can, we know from animal and human research, can induce stress responses. So if you're hand carrying the animals, that's actually going to lead to just 2.5 or so meters per second squared, which is the best of all of our options. Metal carts, small and large plastic carts, metal carts with towel in them to help absorb some of the vibration. Ultimately, transporting animals is going to give them more vibration than they'll ever get in a vivarium space. But in the vivarium space, we oftentimes see this 0.5, 0.6, 0.7 even in racks where we see motors going bad. So ultimately, that's an important area to keep an eye on. So some conclusions before we get to some questions here. So these are basically overall findings from all the labs we go into, an overall summary of what we think is important to pay attention to. So the noise that we hear, we use our ears, right, as workers, as PIs, as investigators, as facility directors. We use our ears and eyes and nose to try to determine when there's a problem. Unfortunately, in the facility, we can't rely on that for vibration or noise. The ultrasonic noises we don't hear can have huge impacts on our animals. The vibrations that we can't really tell are there. Sometimes you can put your hand on a rack and you're like, oh, that vibrates a lot. Is that a lot enough? Is it not quite enough to cause a problem? You have to know what the level is. Measurement is key. Documentation is key. So these noises and vibrations are ubiquitous in our facilities. Every facility we've been to has them, and it's just a matter of how bad they are. Are they approaching levels of concern where you throw a red flag up and say, we have to get a new rack motor, or we have to move this rack of animals to a new space, or we have to put a silencer on the ventilation system. Unless you know the levels, you can't really make those determinations. So the variability from lab to lab is great, from room to room is great, and even rack to rack. So within a single vivarium room, we have seen dramatic variation where you'll have one rack that just vibrates violently and produces an ultrasonic noise that is really damaging to the animals in that rack, especially the animals on the top level of the rack. But the next rack will be perfectly silent. We'll have no vibration to speak of, well below the threshold of action, and we'll have really little, if any, ultrasonic noise. Some acoustic noise, of course. Anytime you've got a motor on, you're going to hear it, but a lot of that frequency is actually below what the animals can hear. And this is, of course, introducing a lot of variability. So we're interested in the 3 R's, of course. And as it relates to this confound, we know that we are putting animals in studies that have different exposure histories. It makes no sense that we don't document these problems, that we don't do a better job of controlling them, because it is causing us to use more animals in our cancer studies, in our diabetes studies, and in studies on everything that we do. And it does help explain some of the variability from study to study, some of the lack of reproducibility in some models. I'm convinced is totally a function of this, because I've measured this in so many labs now where there has been a documented problem, and we can help them find that solution. It just makes complete sense that that would be a way to explain some of that variability. So the basic bottom line is that we think every facility ought to be conducting an annual noise and vibration audit. We think it ought to be as routine as documenting where you get your food from, and documenting that the light timer works, and documenting that the cages were changed on this particular day. We think it ought to be a regular thing that is done for the animals, and not just for the animals, but for the science. It is one of these rare areas where the wellness of the animal also benefits the science. Not an especially rare thing. It's really common, right? But that is the point, that the animal's wellness benefits from understanding these variables, as does the science. We also think that in addition to like an annual check, of every room in your facility to see where problems are, we think that you ought to collect some data anytime you have any new construction, anytime you have remodeling going on, anytime you bring in major new equipment, or when you see problems in behavior or breeding. You need to do some checks to see what's going on. For especially sensitive animals, particularly sensitive, we recommend a 24-hour noise and vibration monitoring. This can be done now. We can do this kind of thing where we actually set thresholds and alerts. It can save studies. And fixing or minimizing the impacts of these variables can usually be very simple once you find them. We can isolate them from the animals. We can rotate issues around. We can solve the problems when we find that they're there. So I'm going to stop there, and we've got a few minutes left to go through some questions and answers. So I'm going to, let's see, we've got Leanna here. She's going to help us look at some questions. So we have a good one, Leanna?
Okay, so if you have a question you'd like to ask Dr. Turner, please do so now. Just click on the green Q&A button at the lower left of the presentation window, type your question into the box that appears on your screen, and click on the send button, and we'll answer as many of your questions as we have time for. So our first question comes from Lisa. If computers are kept in animal rooms, will this affect their behavior or stress levels?
So Lisa, the answer to this is that it depends on how close the computer is to the animals, and it depends on what the acoustic profile of that computer is. So bottom line is every computer we've measured will generate some of this, and it depends on its features as to whether it'll spread. So for example, if it's generating a 40 kilohertz sound of 70 dB at the back of the computer, if you've got an animal within 3 or 4 feet of that, it's going to hear it. It's going to hear it as a zzz, 40 or 50 dB sound. It'll drop 30 or 40 dB just a few feet away. So if you're across the room, the animal's not going to hear it. So it basically depends on the pitch of the sound. The higher the frequency, the quicker it'll drop with distance. So we would want to know what the frequency is, and based on that, we could put the computer in the right place. You can also devise little deflectors that you can put at the vent area on your computer where the sound's coming out to basically capture it so that it doesn't spread, so that it bounces around in a confined space. So the answer is it depends.
Okay, so Jeff asks, can you recommend or suggest measuring devices for the ultrasonic range?
So there are a couple strategies you can use. I've talked to some people about using bat detectors. You can get bat detectors for a few $100, $300 or $400 will get you a decent low-level bat detector that can tell you whether there's an ultrasonic signal present. The problem with bat detectors, though, unless you're buying a very high-end one, many thousands of dollars, it won't necessarily, well, it won't tell you how loud the sound is. So this can create a lot of false alarms. And the point here is that if you take a bat detector into your vivarium space, if you point it at a light, if you point it at a blower, you're going to hear ultrasonic noise, and you're going to freak out. But the question is, how loud is it? What's the intensity? So you have to have a calibrated system to do that. And so that's why the higher end equipment that we specialize in we think is important, because you can determine how loud it is and the pitch. So it's good as a screening tool to try to determine where the problems are and to isolate them, but to really study how loud it is and know whether it's actually got an action requirement associated with it. You're going to want the intensity too. So we rent that equipment. We don't like to sell it because it's hard to calibrate, it's hard to keep up. But we rent that equipment, and we can help people come to those solutions.
So Bethany says, recently I was having a lot of trouble getting my mice to breed, so I moved them to the bottom of a rack. At the time, I was thinking that they may be more comfortable in the darker area, but now I'm wondering if it has to do with the noise produced by the lighting. Since the move, my breeders have been having more larger litters. Do you know of any research being done regarding mouse breeding and noise-induced stress?
So yeah, Bethany, the top of a rack is bad for several reasons. Not only are light levels higher up there, but the sources of noise and ultrasonic noise are usually up there as well. So if you've got ventilated caging systems, the blower unit's going to be up there generating all kinds of noise. The lights are going to be closer, so not only the light levels, but the actual ultrasonic from the lights are going to be greater up there. But also the vibration. If you've got a blower unit mounted onto your rack, it's going to vibrate at the top. So we can actually measure the spread of vibration across a rack, and in a lot of studies or a lot of labs, what we see is that the top row of a rack will have a vibration level above the 0.05 threshold, but the bottom one will be down around 0.2 or 0.3. So the vibration actually dissipates as it gets absorbed by the rack and moves down. So the top of a rack is kind of a notorious location. And frankly, you'd probably want to put your least important animals up there, to be honest, as a quick and dirty way to figure that out. So without measurements, it's impossible to know whether it was the light or whether it was vibration or noise, but it's possible all three of them could have had a role.
So Madalena would like to know, is it safe to have phones inside the facility? Not in the animal rooms, but in the other rooms? And what about cell phones?
So we've measured iPhones. We've measured from some other non-iPhone cell phones as well. We don't see ultrasonic sounds coming from them. Everything is encased in the phones really well, so that the ultrasonic that is present is actually bouncing around inside the case and not escaping well. So that's a good thing. They're not generating tons of ultrasonic noise, at least from what we've measured so far. The only reason to worry about it then would be that the ringer might go off, producing a relatively high-pitched sound, but that's kind of going to be low enough frequency as to not be too problematic for animals. So, but bottom line is we don't really see cell phones doing much of any damage.
Teresa asks, how often would you recommend measuring noise and/or vibration levels? An initial assessment of all areas followed by measures when significant change to facility occurs?
Yeah, we really, we're starting to come to the belief, after doing this for a number of years now, that every facility is surprised when we come in to see what we see. And so we really think that once a year, quick noise and vibration audit is a very smart thing to do. We provide that service, and there may be others that do it as well. And you might even have in-house people that could do the vibration. The noise stuff, it's usually hard to find the ultrasonic equipment on hand, even if you have a hearing researcher on campus. But normally the way this works is we come into a facility, we'll spend a day and just go room to room and do just an overall check and give a report. And then we'd recommend just double checking a year later, because the equipment ages, and we have to worry about blower motors getting older and vibrating all of a sudden. So once a year, and then anytime you have major construction going on, or anytime you bring new equipment into the lab, new racks, for example, you'd want to check them, because you just don't know until you measure. So we think it ought to be documented once a year at a minimum, and anytime you see significant changes in your facility.
Anna asks, what do you think about using white noise during a behavioral task to mask other equipments present in the room?
So this is routinely done, often without an awareness of the hearing range of mice or rats. So most white noise generators that you get, if you go to your doctor's office or a counselor, they often do this they will often do this to protect human discussion. Most of those noise generators are playing sound below 500 hertz, definitely below 1,000 hertz. So that white noise is not really white noise that will include high frequency. It's usually really low pitch. So what white noise generators do in a facility or in a behavioral environment often is make it harder for the researcher to communicate, because it'll impede their conversation. So the point is, you have to look at the frequency of the white noise. Is it actually presenting sounds in the frequency range that the rat or the mouse can hear? If so, it might be useful to mask some of those equipment noises to make a uniform acoustic environment. But you have to know the frequency range of that sound to know for sure.
Laura would like to know if there's evidence that relates noise and vibrations with alterations in frequency of diet consumption.
Okay, frequency of diet consumption. So we may be talking about intermittent fasting paradigms, I'm assuming, in animal models. I don't know of any evidence related to that area. You expect that with different dietary regimes, intermittent fasting, for example, you're going to see during the eating phase, you're going to see more noise in the inside cage, as the animals are consuming food. But I don't know the interactions between that dietary regimen and noise and vibration. Actually, I don't know of any data on that.
Sharon asks, what equipment or software do you use to measure noise and vibration?
So the key for noise is to use a 1/4-inch microphone. These things tend to be, well north of $1,000, and when you get a preamp and A to D and a computer connected to it, you're usually talking somewhere in the $8,000-10,000 range for a system. So we have some of our own custom stuff that we make. We have software that we actually are developing. We're actually developing an app right now, an iOS app with a vibration sensing device, Bluetooth based. So you can put a little a little vibration sensor inside a cage, and wirelessly on an iPad or iPhone, you'll be able to measure the vibration levels inside there, and it'll actually show you the thresholds of action. It'll tell you whether you're at the 0.05 level or below or above, and you can document that. So that's going to be ready in the next month. So we'll look for some advertising coming out on that, because that's a really cool device that we think will be important and a big help for the industry. Otherwise, just using a standard noise meter that you buy off the shelf, be careful, because all of our, facilities, health and safety officers or environmental health officers, they'll have a noise meter, but they're there to measure human hearing range noise, and it won't measure these high frequency sounds. So the minute you move to high frequencies, it becomes very complex. The microphones, the behavior of the sound, the way you condition and amplify and digitize that sound is complex. So this is why we actually provide this equipment for people. We will rent it to you. We'll send it to you for a week at a time so you can do the measurements. We give instructions on that. But we don't currently really want to sell it, because it takes maintenance to take care of these and to keep them calibrated and taken care of. And most facilities will need this, for a couple days a year, or anytime they see a problem. And so it doesn't make sense to buy an expensive piece of equipment and train somebody to use it, and then they have to relearn it once a year. So renting it is a pretty good option, we think.
So Bethany asks, is it more likely that breathing issues are due to noise or vibration?
So Bethany, I'm going to spitball this one, because there are no direct comparisons, experiments directly comparing noise and vibration on breathing. There are noise studies on breathing, there are vibration studies on breathing. My hunch, having been into a lot of facilities measuring noise and vibration levels when there are breathing problems, my hunch is that vibration is probably a little more likely to cause breathing problems, because you might think that noise, the ultrasonic stuff, because we don't hear it, it's a problem, but so much of the time a lot of that is blocked by the caging system and doesn't reach the animal very well, but the vibration does. So if I had to guess, I would put it more on the vibration side as being a problem.
So Lillian asks, vibration is highly variable from lab to lab, room to room, but has someone studied the best architecture and material to reduce that and therefore lab research outcomes?
Architecture and material. So there is a lot of research on building structure and engineering that has to do with noise and vibration isolation. There's entire fields out there focused on that. Again, most of that is focused exclusively on human hearing. Vibration seems to be pretty similar from human to animal. So if you can isolate vibration with good construction, you should do that. The problem is macro versus micro. So building engineers and construction firms and designers, they can do a very good job of controlling noise and vibration at the macro level. So what gets sent down, a load-bearing pile, what moves from room to room, what moves from floor to wall, that kind of stuff they can do a good job of with care. But what they cannot control is the micro noise and vibration. So what actually the room is doing, what the floor is doing, and what the wall is doing is one thing, but then what makes it through the casters in the bottom of the rack, what makes it through the rack and to the animal. So we're introducing inside the micro space through our ventilated rack systems, our carts that we're putting in the facilities, and our cage changing stations. We're introducing a lot of this ourselves. It's often not the building. In fact, most of that gets filtered out by the time it gets to the animal, to be honest, whether it's noise or vibration.
All right, so I think we have time for one more question, and that'll be from Richard. He says, many facilities are moving to RFID tags on cages to conduct census. Do you have any information on the amount of noise generated by the RFID readers?
So the radio frequency ID stuff, the frequencies of those RF signals are so high as to not be to not have an impact on the animals, as far as we're aware. The readers themselves, I don't know, because they're going to be mechanical instruments, not unlike a cell phone. They may generate some high pitch. I would have to measure more than one to know that for sure. I have not seen them yet produce noise, but I think I've only measured from maybe one of these things. So I wouldn't know for sure unless I measured. So I'd be careful, but I wouldn't assume that it would actually.
Well, thank you once again, Dr. Turner. If anyone would like a copy of the slides, send an email to Dr. Turner at the email listed there on the slide on your screen. But I think that's it for today. I'd like to thank our sponsor, LabRoots, for making today's educational webcast possible. And then before we go, I want to let everyone know that today's webcast will be available for on-demand viewing for 6 months from today's live event. You'll receive an email from LabRoots letting you know when this webcast will be available for replay. Please share that announcement with your colleagues who may have missed today's live event. Do you have any closing comments?
Yeah, thank you very much for your attention. Know that we at Audiscience Labs, we have dedicated ourselves to understanding this noise and vibration problem and helping you to measure it and understand it yourselves. So please let us know if we can help you in any way. We can dispatch our field technician to come on site and do a day audit anytime. We can do consults remotely. We can do web training to staff, and look forward to hearing from some of you, especially as we have our wireless device coming out for vibration. It'll be a neat tool that I think will help refine our models greatly, now that we'll be able to measure inside the cage vibration levels. Let us know if we can help you with any equipment rental and any advice. So thanks for your attention.